Third objective, understand that chemical reactions involve the making and breaking of bonds and the concept of bond enthalpy. So bond enthalpy. So let's recall, first of all, let's define what's bond enthalpy. So bond enthalpy. For any covalent bond, to break this covalent bond, and there are different covalent bonds actually. So different covalent bonds have different energy, so require different amount of energy to be broken. So bond enthalpy is energy required to break 1 mole of covalent bond. Okay, again 1 mole of covalent bond. So for example, let's say that bond enthalpy. So for example, when we have chlorine molecule, we break this bond. So let's say we break this bond, so this reaction absorbs some energy, and then after that we get 2 moles of chlorine atom. So bond enthalpy is energy required to break 1 mole of covalent bond. So any chemical reaction which involves covalent bonds, so there will be some energy which will be absorbed and some energy will be released when bond is formed. Okay, so bond enthalpies, actually we have different bond enthalpies. So here, for example, we say it's average bond enthalpies. Why average? Because in each case, for example, in methane, so it will not be exactly 413, but for example in methane we have 4 CH bonds. For example in ethane we have 6 CH bonds. So these 6 CH bonds will have different bond enthalpy compared with 4 CH bonds in methane. So collecting all these CH bonds and averaging, we get 413. So we are going to use this average bond enthalpies in our next calculations. So let's come back. So for example, what can I say again? So let's try hydrogen. So HH, hydrogen gas reacting with oxygen. So between oxygen we have double bond, and we are forming hydrogen or hydrogen bond, so water molecule. So let's balance it first of all. So this is for typical reaction, so let's try to put here 2 and 2 here. For this reaction, so we don't know what kind of reaction is this. So for example, is it maybe formation, or is it maybe combustion of hydrogen? Okay, so we don't know, but we are going to find out enthalpy change for this reaction using bond enthalpy. So in this case, what we are going to use, so we know that the hydrogen single bond is going to break, and oxygen double bond is going to be break, and will form oxygen single bond, 4 oxygen single bonds. Okay, what we are going to do is we are going to use the formula. So enthalpy change for the reaction will be equal to enthalpy change of bond enthalpies, so bond enthalpies of reactants minus total bond enthalpies of products. Okay, so for this reaction it will be, so I will have two hydrogen bond enthalpy plus 1 multiplied by oxygen double bond enthalpy, and minus, we'll open bracket, and as we have here, we have 2 OH bond, and we need to multiply by 2, so 2 multiplied by 2 multiplied OH bond enthalpy. So let's try to calculate. So HH bond, so here 436, so 2 multiplied 436 plus O double bond, so here where we have, so here oxygen 495, 1 multiplied 495 in brackets minus 4 multiplied by OH bond. OH is here 463. So let's try to calculate. So 2 multiplied by 436, it will be 872 plus 495 minus 4 multiplied by 463, so minus 1852. So overall 472 plus 495 minus 1852, so we get minus 485 kilojoule per mole. So these all are given in kilojoules per mole. For this reaction, when we form 2 moles of water molecule from 2 moles of hydrogen gas and oxygen gas, so there will be released minus 485, so there will be released 485 kilojoules per mole enthalpy change. So this is how we use bond enthalpy in order to identify enthalpy change for the reaction, for the given, so for any reaction. For example, if it's given neutralization reaction, not neutralization, for example combustion reaction, formation reaction, what else, bond enthalpies can be used to identify other enthalpies and so on. So you need to memorize this formula: reactants minus products in the case of bond enthalpy.